we're told to graph this equation by factoring it first, then finding the solutions. So if we're going to factor this, we need to figure out which method we can use. And to do that, we're going to see that there are 4 terms, which means that we're going to try grouping. So if we try grouping it, the GCF of the first 2 terms is x squared, which would result in an x minus 2. Then we want the second group to be an x minus 2, because if it is, then it's groupable. And it looks like if we remove a negative 1 from the second pair of numbers, then the remainder would be an x minus 2. So since that's possible, this thing will then finish the grouping step by factoring out the common x minus 2. So that's the new GCF, so to speak. And then when we remove that, we're just left with the x squared minus 1. Now, we look at our new factored form, and we see if either of these 2 factors can break down more. Upon analyzing these, this here is a difference of squares. This would be an x plus 1, x minus 1. The x minus 2 is the linear, and linear factors won't factor any further. So this here would be the factored form of f of x, which is nice because then we very quickly know that the solutions would be negative 1, positive 1, and positive 2. So if we're going to graph this now, we're going to plot those x-intercepts. So negative 1, 1, and 2. Looking at the equation, we know also that the y-intercept is positive 2. So I'm going to plot that point. And that's useful because it'll help us guide our connecting at the dots. It'll also help verify that our end behavior looks correct. So based on the equation, our end behavior is going to be down on the left and up on the right, because this is going to be like a positively sloped line, because a cubic acts like a line. So know the end behavior is going to be something like this. And now we just have to connect those dots. So with blue, I'm going to pass through this one, through that one, through that one, through that one. And notice that the curve naturally connected those end behaviors. There was no bouncing through the intercepts because we only had each solution one time.